Welcome to the Real Python Podcast. This is episode 239. What is behavior-driven development? And how does it work alongside test-driven development? How do you communicate requirements between teams in an organization? Christopher Trudeau is back on the show this week, bringing another batch of PyCoders Weekly articles and projects. We expand on our software testing discussion 2 weeks ago by adding behavior-driven development concepts. Christopher describes how BDD correlates with test-driven development and how it fosters collaboration within a team. We discuss building acceptance tests written in plain language and a handy tool for creating them. We also share several other articles and projects from the Python community, including a news roundup, using regular expressions in Python, dealing with missing data in pollers, monkey patching in Django, first steps with Playwright, 3D printing giant things with a Python Jigsaw generator, and a query language for JSON. This episode is sponsored by Postman. Postman is the world's leading API collaboration platform, and they just launched Postman AI Agent Builder, the quickest way to build AI agents. Start building at postman.com/podcast/Python. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Chris, welcome back.
Hey there.
All right, you ready to jump in with another set of news, topics, projects, and
Sure.
continuing a little bit of our discussion from last week,
Part two.
in a way.
Yes.
Yeah.
Yes.
So, all right, let's dig in with some news.
Not the complete flood we had the last time, just a few small things. First off is PyOhio has been announced. It's July 26th to the 27th at the Cleveland State University. Call for papers is expected in early April, if you're interested. Second, what would a week be without a Python release?
Yay.
3.13.2 and 3.12.9 are out, both of which are your typical bug fixes. Over 250 changes included in these, so go get your bug fix on. And speaking of bug fixes, there was a security release for Django, bringing us to 5.1.6, 5.0.12, 4.2.19. So go get your patch on.
All right.
And then you've got a bit of news too.
Yeah. Well, this is something we did together. I think you initially thought of this idea, but we are headed to DjangoCon Europe. And that is, let me make sure I got the dates right. It's coming up in April 23rd, I guess through the weekend, so the 27th. The talks are Wednesday, Thursday, Friday, and we have a session. We're going to be doing a live recording of the Real Python podcast. So you can see us in person if you're interested in coming to Dublin. Otherwise, you can check it out later. But we're both pretty excited about heading out there. I get to check in on my own Bailey heritage there in Ireland. So I'm excited about that. Yeah, I've never been to Ireland, so that should be fun. And I've had organizers on the show before. I'm excited to meet them in person, talking about DjangoCon. And yeah, we'll make it a Django-focused episode, right?
Yes, and we'll probably do some live Q&A. We'll see. We're still trying to figure out exactly what format's going to be, but it'll be interesting to do it in front of an audience. And for those who are present, you'll learn just how much umming and awing gets edited out.
That would be my work. I do. Yeah, I make us sound impeccable. So that'll be fun.
We also have time and may be able to get some recordings of other podcast episodes there.
Yeah.
If you're attending and you've got a pitch or something and you want to come on the show, reach out, and we're looking for guests.
There's some people I'm seeing on the list.
Yeah, there's a couple
that I've been thinking about having on the show for a long time, like William Vincent, who's actually, he just got a new gig working for JetBrains, which is interesting. And then Paulo, I haven't met him or I thought about interviewing him. So there's a few people I'm just seeing on the list. So yeah, if you're interested and you want to bring a topic our way, please let us know. Or you got questions that maybe we can read for the Q&A part. That might be interesting too, if you want to submit them.
For sure.
Maybe toward Christopher's book here too. So
yeah, I'm planning on giving a couple copies away. We'll see how many I can fit into my luggage and not go over the weight limit. So
yeah, cool. All right. Well, that takes us into topics, and I'm going to go first this week. Up on the docket first here is a Real Python tutorial. This is by Ian Eyre. We've featured a few things by Ian Eyre recently. He is a teacher along with writing for us at Real Python, and he's very interested in data science, and he's been exploring a lot of these libraries, and I enjoy that. I like these new libraries a lot, and this week he's written a tutorial that's called How to Deal with Missing Data in Polars. This is a common problem that we actually just touched on our last PyCoders episode where I talked about cleaning data. Much of that article was about pandas, and as many things are out there in the world. So it's nice to see something that's written from this different aspect and using some of these newer tools. Ian focuses on these features and some of these advantages that the Polars library has, including using lazy frames. The piece itself, as a project, he uses a data set from Kaggle that he has doctored or has been doctored for the article's purposes as we go. And it's in a Parquet file, which if you haven't worked with that, that's a newish format for large volumes of data that has compression built into it, which is really nice. And it's much more efficient than CSV. So if you, again, haven't played with Parquet before, it's there and you'll get to learn some of the methods for reading that in there. In fact, you use this Polars feature called scan Parquet, which is a method to read the file into a Polars lazy frame, which sounds like it's creating a data frame there, but they're a little different. A lazy frame from a data frame. In this particular case, you are creating what is more like a set of instructions called a query plan. Once you've kind of set up all those instructions of what you want to do with a lazy frame, you use this collect method to materialize, that's a hard word to say, the frame. And he describes this by this allowing you to optimize the plan and only read the data that it needs, which is, again, kind of the whole point behind it. So both of these tools are great for working with really large data sets where you may only want it to be efficiently reading what you need to work with. He shares 4 possible methods for dealing with missing data. You can recover it, remove it, replace it, or ignore it. Disadvantages and benefits out of all of these: recovering would be ideal if you're the person that was gathering the data, but often when you're dealing with other people's data, that's not going to be possible. So in this case, you are going to skip past the recovering methods. He moves pretty quickly into the other techniques. So to practice removing it by finding out what data is missing using the Polars methods of is null, you get to practice chaining methods together, filtering, filling in null values with something called fill null, which allows you to do that sort of replacement. And then it gets into dealing with potentially data that is not null, not none, or missing. In that case, these are values that maybe were entered in wrong, things that are maybe non-numeric in the numeric field, or things like infinity values, inf or negative inf that you might have seen before. We talked recently about another one of his tutorials where he likes to include these sections where once you've learned all of these methods and kind of seen some basic code about them, you get to practice your skills. And in the Real Python method for doing this, there are collapsible portions of the tutorial that you can then open up. One is there's an exercise, and then you can kind of keep the solution hidden until you want to expand that inside there. So I like that. And the piece also features another Real Python feature that we've talked about recently, which is a quiz that you can then use to test your knowledge. So if you're wanting to adopt some modern data frame file formats and cleaning techniques, I think this is a really good resource for you. And thanks again, Ian.
Yeah, Ian and I were chatting a couple days ago, and he's actually got more coming. So I think we've got an article that's in the queue for specific to lazy frames, and he's in the process of working on something for aggregation as well. So lots more good Polar stuff coming from him.
Yeah, it's nice because, I mean, gosh, it's been mostly Panda stuff my whole career up till I started hearing the inklings of it. And I think a lot of people are looking at the advantages here. And be able to work across all of them if you need to. So.
Yeah. Well, and there was one of the things he and I were talking about as well, just sort of we're both very happy with polars. Pandas is very powerful, but polars just feels a little more intuitive to both of us. So, yeah.
Yeah, I feel that way too. Again, kind of coming from the R world, there's lots of things that can be learned from these other data science libraries to modernize them.
There's a big advantage to coming second. You can look at what the guy before you did and go, oh, okay.
Yeah.
I like this. I'm going to keep it. That's not so much. Yeah.
Exactly. So what do you got here first?
My first article this week is by Richard Terry, and it's called Monkey Patching Django. Richard has built a project called Nano Django, which we've linked to in the PyCoders newsletter, but I don't think we've actually mentioned it on the podcast yet. One of the drawbacks of Django is you need the entire skeleton structure to get going. You can't just spin it up in a single file. And what Nano Django does is hack, and I mean that in the nicest terms, to allow you to do single file Django. There's other projects out there that have attempted this before, but he's actually trying to include the entire structure of everything rather than a subset. So it's kind of interesting. The intent is to make it easier to do smaller one-off type projects. And since you're using Django, if the project grows, you can then transfer it easily to the full structure and not lose everything you've done.
There you go.
So that's the background for the article. But the article itself is really just on the black magic that Richard had to perform to get all this to happen. And it kind of needs to be black magic because Django kind of uses its own dark summoning to bootstrap and work in the first place.
Sure.
So enter monkey patching. If you've not heard the phrase before, this is the process of dynamically modifying already loaded code in memory. So one reason you might want to monkey patch something is to alter the behavior of a library without actually touching the library code itself. So you don't have to submit a GET request or keep your own copy of it because you're doing this on the fly. Monkey patching is a bit of a Python superpower. Some other languages allow this, but it pretty much has to be a dynamic language for it to work. And even if you're not a Django person, this article is kind of interesting as it lays out the process involved and the challenges and why he needed to patch monkey-wise. For some reason, I've got King Louis' I Want to Be Like You, ooh, 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 from the Jungle Book going through my head.
All right, there you
go. I'd whistle a little bit, but let's not get in a copyright battle with the mouse.
Yeah.
Anyway, dated references aside, what Richard needed to do was adjust Django's bootstrapping process on the fly. When you write a Django project, you create one or more apps, which is a dated, confusing name. They're essentially just Python modules with the expectation that they contain certain files. To tell Django that you have an app, you need to register it in a setting called installed apps, logically. Settings are one of those things that go in one of those files that's in the skeleton process. So now you've got this bootstrapping challenge. Inside a Django app, you'll find the code that actually produces a web page, the routes that map URLs to the code, as well as objects that abstract away the database. When you register an app, Django goes looking into that module for the views, URLs, and models files to put all this stuff together. There's other files as well, but let's keep the simple for the purpose of the podcast. Behind the scenes, there is a function call called setup that gets called when Django is bootstrapped. Normally, that's getting called by your web server initializing Django, or if you're running the development server, Django itself is initializing it. The problem is, this is what kicks off the app loading code. So if you register the app without the file structure in place, Django is going to error out because it expects it to be there. On the other hand, if you don't register it, then Django can't interact with it. And although apps are modules, the interface to them is a class. So this is where Nano Django gets all clever, simian even. It monkey patches the setup process, manually creates a stub app class, then registers it after the stage in the code that looks for the files. So Django doesn't look for it because it didn't think it was registered. But before setup is complete, it jury-rigs the registration underneath to get it actually there with this dynamically created class. The Nano Django app class then just points at the functions inside your single file, and voila, you've monkeyed your way into a smaller Django project. Now I've got King Louis being replaced by Mickey Dolenz and Davy Jones. That's a deep cut 90% of our audience isn't going to get, but you're a music guy, so I'd put it in for you.
Yep.
Unfortunately, that's not all the monkey patching necessary. There are other things Django expects that haven't been quite covered yet. The rest of the article goes on with these other things that need to be interfered with. Like I said, even if you're not a Django person, the article's a nice little intro to monkey patching and worth the read. Before I hand things back over, quick shout out to another Django article that we posted recently. This one is called Generating Fake Django Model Instances with Factory Boy, and it's all about the Factory Boy library that helps you automatically create test data, which is almost on theme with the rest of the show.
Yeah.
If you haven't played with Factory Boy before, the library is definitely worth checking out. And the article by Idis Benderatis from the Django Tricks site covers it quite well. Okay, over to you.
I like that this original piece, the monkey patching Django, is part 3 of 3 in the series Abusing Python.
Yes, he's got an entire tag on his website, is Python abuse. Yes.
Yeah. Postman is the world's leading API collaboration platform. Trusted by over 35 million developers and 500,000 organizations worldwide. They just launched Postman AI Agent Builder, the quickest way to build AI agents. With centralized access to the latest LLMs and APIs from over 1,800 companies, plus no-code workflows, you can quickly connect critical tools and build multi-step agents, all without writing a single line of code. Start building smarter agents today with Postman. Visit postman.com/podcast/Python today. That's postman.com/podcast/Python. Well, yeah, you're right. This is a very testing heavy episode. So mine is about a tool called Playwright. And this is a very quick tutorial or blog post. It's by Nicholas Frankel, and his blog is titled A Java Geek. So don't hold that against him. This piece is titled My First Steps with Playwright. This tool has come up a bunch of times when discussing other web tools and testing frameworks. And the one most recently I think I mentioned was when Simon Willison was on. His tool, Shot Scraper, actually uses Playwright behind the scenes to do that grabbing of an entire website vertically into one big screenshot, which is really nice. So there's a lot of Playwright running behind that. Nicholas wanted a way to automate getting social media account statistics out of LinkedIn, and that's something that just isn't in their API but can be displayed on the web page if you're interested. So he thought, well, maybe I can find a way to quickly scrape this and maybe automate a way to do that so I don't have to keep checking it. And it's a little complicated because, often you'll need to log in depending on the browser, and this thing is kind of creating its own browser instance. So there's that kind of back and forth between those types of things. And so that this article dives into that. Get your credentials ready if you're looking to do this. He takes you through his thought process with a flow chart showing all the different actions that are needed. And then Playwright offers 2 methods of diving into a web page. One is a synchronous way of working or an asynchronous API. And he chose synchronous, which actually makes probably the most sense if you're going to troubleshoot it. If you're not going in a headless mode, you can watch as the web page is going along and Playwright is doing its work. So he builds this script up, and you're making a context manager, and then you're creating instances of Playwright's browser object and page object, and then you're navigating the web page with something called go-to, and then you're finding fields and logging in, and eventually getting to the dashboard area for the different stats, and then pulling them out. So he takes you through the process of then optimizing this to manage this better and find a better way to stay logged in using an auth token, which is a feature that Playwright has, which he kind of figured out as he kind of went through the process. And you can launch a persistent context. If you've never explored working with a tool that can automate doing all this and using a web page, either headless or not, I think this is a really great place to start. It's, again, very short. His code looks a bit different. Part of that is Playwright. Part of it, as Nicholas has admitted, that he's a Java guy and he's new to working in Python, so his code looks a little different. The docs on Playwright's site have good code samples for working with and managing all the different components that make up a web page. So that, again, it's a testing framework. In fact, that's their thing that it's described on their site as end-to-end testing for modern web apps. But you could use it for other things than just testing, as you can see here, either in Simon's example or his example. You could use it for giving you other ways if an API isn't available to get information out of a site. Again, their documentation's really good. It has stuff on navigating, dialog boxes, frames, authentication, APIs, and so forth. So thanks, Nicholas.
Yeah, 2 episodes ago when we got deep into testing, we chatted very briefly about Selenium, which is an equivalent tool from these. So if you're looking into those, both of them are worth checking out. Playwright's a little newer. Selenium, from what I've seen, seems to be a little more robust. Like you can take it up to the level of, I want to do this on 50 servers and test a whole bunch of things at once.
Yeah.
So it's a little more frameworky, but if you just got to get something out there quick, Playwright's an excellent tool. Now someone's going to pop up and tell me, but you can. So maybe you can. I just haven't done it myself.
Yeah.
My next article is by Federico Trota, and it's called How to Use Regular Expressions in Python. There's a quote that's been kicking around the internet since 97 that goes like this. Some people, when confronted with a problem, think, I know, I'll use regular expressions. Now they have 2 problems. The quote is from Jamie Zawinski, and although regexes can get you into trouble, they're a really powerful tool most programmers really should have in their toolkit. If you've never encountered them before, regular expressions are a little mini language unto themselves that's built into Python and pretty much every other programming language out there.
Yeah.
You use this mini language to search and match values within a string. So if you've ever used Python's in operator to check if a string is in another string, so like I'm looking for monkeys in the phrase, hey, we're the monkeys. See, look at that, a callback. Then regular expressions are basically that, but on steroids. And like steroids, if you're not careful, they can have some unhealthy side effects. So,
hence the multiple problems.
There's multiple problems. That's right. Now you have 2 problems. A regular expression is itself a string. And in fact, in their simplest form, you can do what is known as literal matching. That's literal as in string literal, not literal as in the word literally that somehow has come to mean the opposite of its definition.
In most uses, yeah.
In my previous in example, the literal would have been the monkeys that I'm looking for in hey, we're the monkeys. Where regular expressions shine through is when you want classifications of matches. So, for example, instead of looking for monkeys, you could look for any word that begins with M. Regular expressions use meta characters to describe different kinds of matches. So, for example, an asterisk means to match any number of characters. So M star would mean a substring that has M in it and every character after it. And this is where things get messy. You remember when I said I want a word that begins with M? Well, M star isn't actually that because regexes don't care about spaces. So you'd get monkeys and everything after it as well. So by combining different kinds of meta characters, you can get closer. So for example, you could say all matches up to and not including a white space character, and that's a start, but it wouldn't completely solve the word problem. It would also include words with M in the middle. You could say white space meta character before the M as well, but then that doesn't match if a word starting with M is at the beginning of the string, as there wouldn't be any white space before it. Same goes for punctuation like quotation marks or periods. So if you don't have a space after your period, you're going to lose it as well. So there's solutions to all of these problems, and a podcast really isn't the right place to learn such a visual thing, but regular expressions can be a bit tricky, but Federico's article walks you through them step by step. Topics include searching, matching substrings, groups, look-aheads, and look-behinds. Those are ways of matching based on something that comes before or after your match. So it's kind of like a conditional. So after covering all that, the part that I really like is he goes on to show some real-world examples to help you better hone your skills. I do have one nit to pick, though. One of his examples is using a regex to match an email address. And although his regex works for some email addresses, it actually doesn't follow the full spec.
Right.
If you've ever had your valid email address rejected for a username, it's likely because someone has done exactly what he's doing in the article. Don't get me wrong, it helps you understand the concept of a regex. Just don't please use it to actually validate email in your code.
There's a little bit more to it.
You generally shouldn't use a regex to validate email, and a fully compliant RFC 822 regex is over 6,000 characters long. We'll include a link in the show notes just in case you want to take a look and you're curious.
Enjoy!
Exactly. And in fairness, the post that talks about this particular set of characters, no one actually wrote this. Somebody wrote some code and then used a parser to translate it into a regex, because I don't know how any human being could have done this. It essentially looks like line noise.
Yeah.
Anyhow, my nitpicking aside, Federico has done a great job of writing an intro to regexes here, and the article's definitely worth checking it out if these are things that are new for you.
Yeah. We have some resources on RealPython. In fact, Mr. Trudeau did a course on regular expressions, so that might be another way for you to dive in. It's been a while.
Yeah, one of the challenges is regexes is if you're not using them regularly, they melt away from your brain. And so, by the time I had the course built, I was like, yeah, I can use this more often. I understand. I'm sure I'm confident about this. And then I didn't use it for a couple of years, and now I'm like, okay, I know I can do this, but how do you do this? So so if you
go watch yourself talking to yourself.
If you bump into me on the street and go, that was a great regex course, could you explain to me how to do X? The answer is probably no. I probably can't. Not without looking it up.
Yeah, it's kind of a funny one with all this stuff. So this week, I want to shine a spotlight on another RealPython video course. It covers a topic we touch on during this week's episode. It's titled Regular Expressions and Building Regexes in Python. The course is based on a tutorial by John Sturtz. And in the course, my co-host, Christopher Trudeau, takes you through practicing the fundamentals of building regular expressions, like matching meta characters, regex, anchors, and quantifiers, and how grouping works. Then you'll learn how to implement all of those skills inside of Python, using the RE module, accessing the groups found, substitutions, splitting and escaping, and how to create flags, plus several more advanced matching techniques. I think learning how to harness the power of regular expressions is a worthy investment of your time. String matching like this is a common task in programming. You can get a lot done with string operators and built-in methods, but at times you're going to need these more sophisticated pattern matching capabilities. Like most of the video courses on RealPython, this course is broken into easily consumable sections. Plus, you get code examples for the techniques shown, and all our courses have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. All right, well, I think that takes us into our discussion. And again, we have already hinted that it's going to be about testing. So you ready to take off this?
Yeah, sure. So in 237, our last PyCoders episode, we talked about unit and integration tests. That discussion was actually coincidentally based on an article by the same Federico Trudeau that I just mentioned for regexes, which I didn't realize when we picked out this week's article, but there it is.
Okay.
So there is a companion piece on the same site by Antonella Zanini titled TDD versus BDD, What's the Difference? So we figured it would be a nice little follow-on discussion. In case you didn't listen to 237, a quick recap. A unit test is a piece of code that tests a small functional unit of your software. Doesn't have to be, but it often tests like a single function or class. And then an integration test is one that tests combinations of things at a higher level in your code. Although the line between these two things is very blurry, especially seeing as you often use unit test libraries to write integration test code. So the vocabulary is a bit messy.
Yeah.
This ties back to the testing pyramid. There are many versions of this, some with 3 simple layers and some with many more than 3. For today's conversation, we're going to be talking about a 4-layer pyramid. At the base is unit tests. Above that is integration tests. Above that is system or application tests, and then GUI tests sitting on top. Some pyramids ignore the application tests or consider GUI and application stuff the same. So I might use Python's unit test or something like PyTest to do the unit and integration levels.
Right.
And then at the GUI level, we'd be using things like Playwright and Selenium. And TDD is kind of independent of that, and BDD is at that application level. So we'll come back to that and sort of tie it all together.
Okay.
So first acronym in the article's title is TDD. That stands for Test-Driven Development. This is a process or a mindset or a philosophy. There's some people who take it to the level of a religion. And the idea essentially is...
Does this lead to the pyramid schema of the scheme?
Something along those lines, yeah. The core idea is that you should write your automated tests before you actually write your code. So it goes like this. Write a test for your new feature, then write the smallest amount of code needed to pass the test. If it passes, you can stop. You're done. You might want to do a bit of refactoring. And if you don't, great. And if you do, then it's nice that you've got a test that ensures that your refactoring didn't mess anything up. So TDD comes out of Kent Beck's extreme programming, which was an early agile methodology. It actually predates the term agile, and it's what Scrum blatantly ripped off. There's a lot of commonality between those two. So if you're familiar with Scrum, you probably know XP, even though you don't even realize it. The driver behind TDD is a couple of things. First, it ensures that you've written a test. If you write your tests after you write your code, deadline pressure might make you cut corners and you might skip writing the tests altogether or not write good tests. So by writing the test first, you're pretty much guaranteed to have a test. It's kind of the definition. And then the second driver is that TDD tends to prevent gold plating. And that's the process where a programmer adds features that the business didn't really want because you go, oh, I'll just add another thing. And so if you write the test to the actual requirements, the test passing is a nice little signal to stop. When it passes, you're done. Move on to the next activity. So when I sell this to the business, I usually sell the second thing. And when I sell this to programmers, I sell the first. So it depends on who you're talking to. But so that's the general idea behind TDD.
Got to know who you're pitching. What's the audience?
Exactly.
I want to ask you about gold plating. I haven't heard that as a term. I've heard of polishing things of various types, but do you have an example of like that happening or examples of what people try to do with it?
Yeah, the first time I think I came into it was one of the developers who was on my team. He kind of like disappeared for 3 weeks and like rebuilt this widget from scratch because he thought it would be cool.
Okay.
And the business didn't want it. It was pretty, but it wasn't something they were asking for. And he probably could have spent his 3 weeks on something far more effective or far more important to the business. And in fact, it was a failing of me as a manager to not realize that this was happening and head it off before he wasted his time. It doesn't have to be extreme, but like when you're coding for yourself,
right?
You always go, oh, this would be a neat feature, and I might be the one who's using it, so I'll add it. It's a neat feature. Great, right?
Right.
I'm playing around with SQLite and full text search right now, and I'm going to be adding a advanced search, taking advantage of some of the things that SQLite uses. I suspect even I am not going to use it, but by putting it in the library, I'm learning it, and so I'm adding code.
Right. When
you're working for the business wants something, and they want to pay for that something, and they don't want other things.
Yeah.
And I'm not getting into the design or bad design or whatever. I just mean don't add features they aren't asking for. Go and work on the next feature. And so that gold plating is like spending too much time on something.
Yeah, I mean that's I think a tendency that developers have, that they want to learn new things. And it's interesting because this industry is a mess.
It's complex.
From a headlines state, it's like, okay, well, how many people got laid off? And it's never like denoted like what areas and so forth. But I know there's got to be a lot of developers there. And I feel like in that, this idea of like, we're going to become extreme, go back to that word. When I got into this 6-7 years ago, there was this concept of like having time inside of an organization that was, hey, we're going to let you have, 20% of your time where maybe you could go off and learn. Whereas people who don't have that might maybe use that gold plating type of technique to, hey, I'm going to learn this. I'm going to go ahead and build it on this project because it's code that I get to touch every day. And I can kind of like use that as an excuse for building something inside the project. And maybe that is a good reason for having that separate time where you can work on your own projects and learn.
Yeah, it's not... I
don't know if it's necessarily related.
It's not necessarily a purely bad thing, right? Like the things that the business feels are gold plating, the developer might think are necessary. But
right, you got to argue it and figure out how to communicate it.
a common thing I find, like I do this myself, which is I'll over-engineer something, right?
Sure.
You'll go, oh, okay, if I might use this in the future, so I'm going to make sure that it has a clean API, and I might do this and that, so I'm going to change so that this is all options and configurable, and then I never use any of it, and so that's gold plating and a waste of time, right? So, like I try to follow the rule of the second time I need a chunk of code, I'm going to copy and paste it. And then like the third or fourth time I need a chunk of code, that's when I'm going to turn it into a library, because that's when I really understand how I'm going to reuse it. Whereas if you're building something that's reusable from the get-go, there's a chance you're never going to reuse it, or you're over-engineering it. And gold plating is kind of that kind of thing.
Okay. Kind of going through, like in the article, and I'm guessing when this is taught, the idea of the phases that they talk about, the green, the red phase, the green phase, and all that sort of stuff. Red phase being writing the test, green phase making it pass, and then they kind of have like a blue phase in there, which is refactoring. So red, green, refactor. I'm intrigued by that. Is it possible during the green phase that some people write code that tends to maybe not be optimizable, like stuff that you might have to just totally throw out in order to match the patterns that are used by a team? Like, I'm wondering, like, structurally, you have all these different people on the team. Do you like enforce standards for like, okay, this is how tests are written, and then this is how we should approach like solving them? Because I'm intrigued by this whole like the idea of like, okay, then it needs to be refactored, or maybe you just get to the point where like, well, it passed. I wrote code that passes it.
Well, testing in general allows you to draw boxes around things. And what I mean by that is it might be a little like you could have 10 boxes that are the different chunks of your code. And if your code is using well-known interfaces to talk between those boxes, then if one of the boxes is a little messy, then you can replace the box as long as the interface is the same. And test-driven development doesn't require that, but it helps it, because in order to write the test first, you got to think about what the interface is going to be.
Okay.
So you're thinking, what arguments is my function going to have?
Yeah.
Why would this function need these arguments? And then you're going to write a test going, well, I'm going to pass in these 3 variations and these 4 variations, and these are my corner cases. And then you write the code. Well, the end result of that is you've drawn this clean little box around it, because you're using that interface, which is the same interface that the test used to talk to it, right?
Right.
So it kind of helps subtly enforce encapsulation a little bit.
Okay.
And if it is a little messy inside, as long as you don't break the entry point, as long as you're using the same function definition or the same API, you can change the code. And in fact, this is one of the things that there's a side effect. Like, tests are good because we end up with higher quality code. Automated tests are good because manual is slow and expensive.
Right.
But there's a side effect that I really, really like, which is it frees developers up to, there's a safety net, right? So if you have an idea of how I'm going to make this function run faster, and you're not 100% sure how the function works because somebody else wrote it 3 years ago and it's crufty and it's overly optimized, there's a chance that when you go to try to fix it, that you're going to introduce a bug that you're not expecting to introduce. And so the default is it's working, leave it alone, don't touch it. Whereas if we've got a good test harness to go with it, you've got that safety net. You can go in and you can muck around.
Yeah, that kind of came up last time when we talked about this stuff, yeah.
And then you go, oh, look, the test passed. So, right? So this refactoring piece is kind of connected to that same thing, right? Like if you didn't do your best, or you come up, you go and you get the test to pass, and then you go get one of your colleagues to do a code review and they give you some feedback, then you can go and muck with it a little more, and all you got to do is recheck with the tests, right?
So I feel like all this isn't necessarily answering, where we're headed in this conversation of BDD. And I feel like part of it you kind of hinted at when you started to talk about like the idea of like, well, what are the tests that we're writing and so forth, and, answering those questions. And as I read through this article and I looked at some of the additional resources, I was like, oh, this makes sense, because now you're talking to people that are not developers, potentially quote unquote stakeholders and non-devs and other people that are going to use this tool to come up with the tests? Is it kind of predate the process sometimes or not?
Yeah, it doesn't have to be just the test, but that you're heading closer to the requirements. So unit level testing tends to be under the covers, and the business wants it to work, but doesn't necessarily care.
Right.
BDD is at a higher level. So maybe we should do a little spiel on that, and we can come back to it.
Yeah, sure. More acronyms.
Exactly. So BDD stands for behavioral driven development, and you can kind of consider it an extension to TDD. Me saying that out loud is going to have pissed somebody off, but let's go with it. So it typically comes into play.
They don't listen to this show.
Nobody. Yeah, sure. Yeah. So it typically comes into play higher up in the test pyramid, and it involves something called ATDD, which is acceptance test driven development. So the idea here is, even before you start writing the function that you're going to test with TDD, you write some tests about how the application is supposed to behave. And this is what I mean by higher level.
Yeah.
So this is like a top-down or outside-in kind of approach. If you're familiar with user stories, which are just another way of capturing requirements, they're popular in Agile, but they aren't specific to Agile. A user story includes something called acceptance criteria, and that defines what a feature should do in order for it to be accepted as complete. So BDD is essentially the TDD concept, but applying it at that acceptance level.
Right.
And because those stories are being written by the business, that acceptance level is high level. This feature will behave this way rather than this function will return this value.
Okay.
So to do BDD well, you have to properly understand the requirements that are associated with the acceptance criteria. So even if you're not using user stories, you need a list of things that define that the feature is working. And then you write high-level tests to check this, and essentially you're using that TDD-like approach where you're working on getting the tests to pass by writing code a bit at a time, right? So TDD is more or less kind of philosophical. You can write your tests without TDD, but BDD tends to move a little more towards requiring specialty tools. You can do BDD with the same tools you're using to write integration tests, but there's libraries out there that can help you go a lot further. One of my favorites, one of the more popular ones, is called Cucumber. Cucumber is a cross-language BDD framework which ties a domain language to user tests. So the thing I like the most about this is that domain language reads like English. So It's not a fancy AI tool. You can't just write any English and it'll work. You have to learn the syntax. But someone who doesn't have the training and hasn't learned the syntax can still read and understand the scripts. So you might have a test specialist write in Cucumber. Technically, their language is called Gherkin, but that's for another day. You can write in the scripting language, and then the business can go off and read it. And so that means your management can see exactly what you're testing. And this helps a lot when you're convincing the business folks that the idea they gave you has been captured properly.
Right.
Cucumber uses a given, when, then format. So to perform any test, even a manual one, you need three things: the current state of the system, the thing you're doing to the system, and the expected outcome. So this is given, when, then. Given, I'm on the login page. When I enter the username and password, then I'm granted access. What Cucumber does is marry this kind of scripting with the underlying unit tests and code. So the Cucumber script then calls the unit tests, and it ties all those things together. And one of the beauties of this, there's often a bit of a challenge with automated testing. The old style of testing when it was manual was you've got 4 or 5 developers and you've got a QA person to go with them. And then they manually test something. And the 4 or 5 developers produce way too much code and not everything gets tested. So if you want to write automated tests, you can't have the QA person be doing it, because 4 developers producing feature code are going to be able to create more things than the QA person's ever going to be able to keep up with.
Yeah.
And so one of the other advantages of this Cucumber mechanism is it's a higher level script. So you can have the QA person write the Cucumber, and then the programmers write the harness that connects to the Cucumber. And then the QA person can go in and change it. So that login page example that I gave, in Cucumber, you can define a table with this is the username, this is the password. The QA person could then go in and add another username and password for a different test, and the programmers wouldn't have to touch it. There's a natural separation of concerns between the roles that kind of happens with using this kind of tool.
I guess I have some questions about partly we've already described some of like when this happens, like when in the process someone would write this sort of stuff. I'm guessing it kind of happens across the development process, but is it something that usually is happening pretty early that someone's going to write these things inside of the cucumber gherkin like syntax?
So if you are applying this religiously, following TDD as it's supposed to be, then you're supposed to be doing all this work before the code kicks off.
Okay.
A lot of organizations, and I can tell you myself included, bend that rule a lot.
Okay.
So my primary concern when I'm managing teams with this stuff is that the tests get written.
Right.
So as long as we're not cutting corners and not writing the tests, does it matter if you write the code first and then put the layer on top of it? I don't think it's that big a deal.
Okay.
As long as no one comes and pulls the rug out from under you and go, oh, well, the code's done, don't write the tests. So if you've got a good shop if you've got a healthy dev shop that knows writing these tests is important,
right,
I really personally don't care whether you come at it afterwards.
Okay.
And again, it was something like Cucumber, you'll get that division of responsibility. So you'll have some sort of business person writing the user story. The QA person will go start writing the Cucumber. They'll have a conversation with the dev people about how the Cucumber is going to glue in with the unit tests. And they'll either start writing that because they're doing TDD, or they'll go and write some of the code and then write that and then wire it all together.
Yeah.
And at some point, they'll run the tests and they'll figure out that they weren't talking to each other properly, and then they'll have to fix it.
Yeah,
and then once you get it to the place that it passes,
update all that stuff.
Then you're good. Yeah.
Okay.
Yeah.
Do you feel like it helps clarify the goals in this process?
Yeah, it definitely, both TDD and BDD make you sit down and have to have a bigger idea about, what is this going to do, right? So like traditional waterfall development, there's always this feature is a nice to have. Well, at some point in time, somebody's got to make a decision. Are we building it or are we not building it? And so this acts as a bit of a trigger, right? Like, we're handing this off to dev. Here are the things it will do. There's no conversation about nice to have. We're building this or we're not building this, right? So it does sort of force the formalization of it. And that's one of the reasons I really like Cucumber, is because it also gives you pushback to the business of saying, we discussed it's going to do this. This is the formal spec almost. It's not quite a spec because it's your tests.
Right.
You can read it like it's a spec. You can hand it back and go, hey, this is what it's planning on doing. And then the business can go, oh, wait, that it's not supposed to behave that way, or it is supposed to behave that way. So you shorten the feedback cycle to find out about those things more quickly.
Okay. Have you found times where this process actually is like a hindrance or confuses things? I guess it depends on how well your team is working together, I guess. But.
Yes. Fundamentally with all these things, it's always humans, right? So like, I remember talking to a manager a while back, and I was like, what do you mean you're not doing unit tests? And he was like, well, we were doing unit tests for a while. And then I started doing code reviews on the unit tests. And what I found out was they were writing the test, and all the test said was pass. It wasn't actually testing anything. I'm like, well, yeah. So yes, that you are correct. That is a waste of time.
Yeah.
But and that comes about from your standard human thing. They were measuring the wrong thing. They were measuring the number of tests rather than measuring the code coverage, right? If you measure actually how many lines of code got executed by running our tests, you wouldn't be able to play that game, because you'd have 300 tests that said pass and your code coverage would be 0%. So right, so people will be people, right? And it's So it's hard to divorce that from culture. And one of the challenges with this stuff, I spend a lot of time talking to companies about agile and agile transformations. Sometimes there's a bit of a cultural pushback on some of these ideas, and TDD, BDD, and a whole bunch of other things like CI/CD and a lot of that kind of stuff often gets referred to as agile engineering. And then people want to throw the baby out with the bathwater because they think it has something to do with the agile transformation. And these are modern engineering concepts.
Right. These are tools.
And if you're doing waterfall, you could do this. There's no reason why you can't, right? Just because the agile people invented it doesn't mean it's a bad thing because you hate agile, right? So you get into some sort of cultural type back and forth because this is This is very seldom showing up in an organization on its own. It's usually coming with a whole bunch of other stuff.
Yeah, just because they're be zealots doesn't mean that this is a bad thing.
This is a bad one, right?
Other. Yeah, there can be some good tools there. Well, I think that, without us diving into an entire testing episode, I think this covers a lot of the concepts, lots of fun acronyms for us to delve into, and maybe we'll come back to it a little bit more. It seems like Semaphore is on a roll with this stuff, which has been kind of nice as a resource for us to come up with discussion topics. So
and if you're interested in digging into it a little further, the article also includes a lot of like tool references and example code as well. So if this is something that you're
not purely Python though, so just be aware.
No, but you do see the pieces that are there. So there's plenty there to dig into if you want.
Yeah. Well, that takes us into project. My project isn't purely a typical GitHub repository type of thing. I just found it and I thought, well, this is really interesting. And it does come with some code. It's it comes from Cal Bryant on their blog. The post is titled 3D Printing Giant Things with a Python Jigsaw Generator. If you're ever shopping for a 3D printer, one of the big things that came up, at least for me, when I went to go shop for one, was how big of things do I want to be able to print? And bed size, literally the area that you're printing on, to me I had to really think about it because I wanted to make some fairly large things like cases, stuff that could encase and hold other stuff. I wasn't going to make like figurines or other kind of like artistic things with it. I was going to build lots of functional stuff. And being a guitarist, I like to build things that I can step on. And so I needed like a medium or moving toward larger bed sizes. And so sometimes you're throwing out other features then in that case, like speed or some other kinds of details. Anyway, I'm pretty happy with the size of the one I have, but this really intrigued me when you shared it inside of PyCoders. Cal has like this journey across this whole thing of developing kind of a dovetailing tool written in Python, and it can split a very large print that's coming in an STL format into separate parts that can be then joined together using these dovetail joints at all the different divisions. He provides videos of his inspiration. There were some of these really large prints for an arcade cabinet that was basically recreating something from the 70s. There was like these 2-player games that Atari made. One was called Space Race, and the original case was actually made out of like formed fiberglass. And I'm guessing that, if you don't have those kinds of tools for working with fiberglass, it would be expensive. And a lot of people have 3D printers and have leftover scrap stuff. So he shares this video from this guy named Richard from RMC 3D Prints, and they're recreating it and they're gluing all these pieces together to create this final product. So it's a really interesting kind of watching through Cal designing the jigsaw, like dovetails, and how they create these really solid connections, and they allow for gluing to be a lot more effective. He actually has to go through this process of, okay, well, what's the geometry? And then, of course, the math of like taking apart this. And he uses a variety of different libraries and tools. He seems to be a fan of OpenSCAD or OpenSCAD. I don't know how do they pronounce it. He mentions another library in this domain called, I think it's going to be pronounced TriMesh. You end up with this .py file that he gives, and he lists different libraries that it requires. Doesn't actually provide a requirements.txt, but I think pretty quickly you could maybe use that lovely new inline metadata trick that I talked about with Charlie Marsh about UV that you could use to include in this script if you wanted to. That is a nice feature of UV. So yeah, if you're interested in doing really large prints or even just medium large prints, this is a way that you could take that scaled up STL file and divide it up and have a way to combine it all together.
When you said guitarists like to step on things, are you talking about trashing hotel rooms or did you mean pedals?
Usually guitar pedals, which I have a lot of. I've always been a pedal kind of guy.
Fair enough.
But I've also like using my feet to control other things while I play guitar, be it like software and stuff like that. So
got it.
Lots of foot switches.
There you go.
Cool. What's your project?
I've got a query language for JSON called jmespath, all one word, and the A isn't in the James part. It's by James Sire-Winnie and Sen McGrail. This is actually more than one library. It's available for Python, JavaScript, PHP, Go, Rust, and Ruby, and there's even associated command line utilities as well.
Wow.
So if you've ever used XPath to find things inside of an XML document, JmesPath is like that, but for JSON. So in true programming tradition, the first example on the README page is a dictionary with a key, foo, that points to a dictionary with a key, bar, that has a value, baz. So we've got some nested dictionaries going on. If you do a JmesPath search on it with that JSON, using the string foo.bar, you'll get back the value, baz. So it's a short form way of getting at deep parts of your JSON. It's kind of funny that we picked this one this week, as this is almost like a lightweight version of a regular expression.
Yeah.
But for accessing parts of a JSON structure, so even our callbacks have callbacks. The JmesPath language uses dots to do attribute access and square brackets for getting at list indices. And you can also provide an asterisk as either an attribute or an index to do wildcards. Like Python, JmesPath also supports negative indices to get values from the end part of lists. So the library comes with two main functions: search, which searches for a result in your JSON, and compile, which creates a reusable expression, which is more efficient if you're going to be doing the same lookup over and over again. And regular expressions in Python support the same thing for the same reason. So the JmesPath mini language supports a variety of functions for dealing with different kinds of data types, and it also lets you write your own as well. So it's hookable and playable and very flexible. If you deal with a lot of JSON, this is definitely worth taking a look at.
Yeah. Cool. All right. Well, thanks for bringing all these articles and projects this week, Christopher.
Cheers.
Talk to you soon. And don't forget, Postman is the world's leading API collaboration platform. And they just launched Postman AI, Agent Builder, the quickest way to build AI agents. Start building at postman.com/podcast/Python. I want to thank Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.